Dear students, in this lecture, we see about the nanoparticle. I gave a brief introduction to nanoparticle, but the main course of this study is thin films. But still, let me give you what is nanoparticle and what are the ways we can synthesize nanoparticle, and then we get into the thin film nanotechnology. So, what do you mean by nanoparticles? So, nanoparticles are particles of size between 1 to 100 nanometer. If the particle size is between 1 to 100 nanometer, we say that it is a nanoparticle. The sizes can be either in only one dimension, or it can be in two dimension, or in all the three dimension. For example, so one dimensional nanoparticle means it is thin film, where the thickness alone it is in one dimension. The other two dimensions are in larger dimensions. And two-dimensional nanoparticle is example is nanorod. It can be in nanorod or nanowire, where the larger dimension is length, the other two dimensions will be in nano range, which means the range is between 1 to 100 nanometer. And three-dimensional nanoparticle, in all the three dimensions it is in nano dimension, which is between 1 to 100 nanometer. In that sense, nano powder is the example. So here in this unit we are going to focus on one dimensional nanoparticle, which is thin films. 1 nanometer is only 3 to 5 atoms wide, so it consists of very low number of atoms, and the width is very small. And the comparison, what is the nanometer compared to several other uh, particles like human hair, and to the size of atom, to the size of protein, it is mentioned here. So one nanometer particle is 40,000 times smaller than the width of average human hair. The comparison of 1 nanometer to human hair is nearly 40,000 times. And 1 nanometer comparison to hydrogen atom is mentioned here, 0.04 nanometer. Protein is of the order of 1 to 20 nanometer. And the size of computer chip is 180, human hair is 10 micrometer. So what is the specialty of the nanometer? At nanoscale, the physical, chemical and biological properties of materials differ in fundamental and valuable ways from the properties of individual atoms and molecules or bulk matter. So when you go to nano range, all the properties changes. Okay, so for example here some of the properties are mentioned. So catalytic activity, so better catalytic efficiency through higher surface to volume ratio. So surface to volume ratio, it plays a very important role. So which means because if you see the surface area, for example if you take a cube, the surface area will be 6 a square, and the volume is a cube. In that sense, the surface area is increases of the order of a square, and the volume is increases of the order of a cube. If you find the ratio, when it go to nano range, the surface to volume ratio will greatly increase, and due to that is the main reason, which means that more number of atoms will be in the surface when compared to the bulk. So that is a very important reason why it possesses a very excellent behavior. An electrical property, increased electrical conductivity in ceramics and magnetic nanocomposites, increased electrical resistance in metals. So the electrical property changes, there is a change in magnetic property, increased magnetic cohesivity up to a grain size, a super paramagnetic behavior. So it can also exhibit super paramagnetic behavior. So in that sense, paramagnetism and superparamagnetism are materials which exhibit hysteresis loop with very low, negligibly smaller cohesivity and retentivity. So that is a super paramagnetic behavior. And apart from that, the mechanical strength is improved, the optical property has been improved, and spherical activity, increased selectivity, hollow space of a specific drug transportation and controlled release, and its biological property increases. Almost all the properties increases at the nanoscale. And how the nanomaterials exist. So various nanomaterials and nanotechnologies. It can exist in as nanoparticle, nanocapsule, nanofiber, nanowires, nanotubes, nanosprings, nanobelts, etc. So we are going to deal with nanofilm, thin films, and how do we can synthesize this nanomaterial. So nanomaterial can be synthesized by two main approach. One is the top down approach, the other one is the bottom up approach. So top down, as the name indicates, from a bulk material it is crushed to powders. From bulk material crushed to powder. And bottom up approach is by building up atoms to atom. From atom by atom we build up, and we get to a nano powder. So building complex system combining simple atomic level components, that leads to the bottom up approach. So methods for creating nanostructure and mechanical grinding, which is the top down method, and wet chemical synthesis. Bottom top down exist as well as bottom up exist, and most of the wet chemical process are bottom up approach rather than top down approach. And we are going to see the wet chemical synthesis as well as the top down approach as well as the bottom up approach of thin film synthesis. So what are the requirements of a very good thin film? We see the requirements of a thin film. The deposition must be uniform throughout the wafer. If you have a substrate, over a substrate we used to grow the thin film, the wafer must be uniform deposition. A very good control is necessary to get a homogeneous synthesis of thin film. The admitted level of variation is 2%. In that sense, it should be a uniform thickness. In one region it is having a higher thickness, in another region it have a very poor thickness. So that should not be maintained. It should be a uniform thickness, and the admitted variation can be only up to 2%, not more than that. And to prepare a thin film, the material should adhere to the water's wafer surface and should not peel off. So the material should adhere to the wafer surface, means to the substrate over which it grows. It should adhere properly. It should not peel off quite easily. And the dust particles should not fall on the wafer during the deposition process, because if any dust particles present, that will act as a nucleation center, and from that a growth will occur. Then it may not be proper. The growth may not be proper. The crystal structure of the film deposited must be sufficient quality, because it will affect the properties of the film. So it should have a sufficient quality in that sense. Even if, for example, if you consider copper, we need larger grain size to get a very good electrical resistance. If it is a very very thin sheet of copper, then it doesn't have efficient quality, and it will not exhibit a proper conducting material. It will behave as a different material. So to maintain its property, it need a sufficient quality. What is this requirement? Depend on that, the sufficient quality should be maintained. In alloys deposited, then the composition must be uniform. So in the case of alloy, the composition must be uniform throughout the process. If it is a two different metal form as a thin film, then in one region 40-60%, in another region 50-50%. If it is of different composition, then we won't get a desired proper material. The composition must be equal in each and every region of the thin film. So these are the requirements for growing a thin film. How this thin film can be grown? The thin film can be grown by several technologies, and among that the main methods are physical vapor deposition (PVD), chemical vapor deposition (CVD), electrochemical deposition (ECD), and spin-on coating. In this, the PVD technique and spin-on coating are purely physical process. CVD and ECD are chemical reaction will occur. In that sense, a chemical reaction will be involved during the process, during the growth of thin film in CVD and ECD, whereas the PVD and spin-on coating, in this it is purely physical process. There is no chemical reaction involved. So with this I stop. In next class we see about the different methods of synthesizing thin film.